more time to hit the ground. That's what I need to do. Woof. Okay. Okay, today in the AP class, we're going to look at what's known as the Young's double-slit. This is an intergalactic problem set of chapter 24, kind of number 8. I'm not going to go all the way with it because I want you to see what it kind of looks like, but it's kind of number 8. Okay. And we'll see some of this build in class. Imagine for a second I have a sheet of material with 2 slits in it, 2 like little holes, okay? And on the back edge I have a large ray of light coming through, okay? Or a wave of light, because we're doing wave optics. We know, because we've seen in class and through Huygens principle, that this light is going to hit the slit and it's going to start coming and diffracting out with wavelets. Okay, and these wavelets are going to interfere. Let's imagine that a very far distance away from this screen, or this barrier here, the slits, I put a viewing screen so that the light should appear on that. We might think, rather naively, that the light's just going to come through here and here, and we're just going to see light here and here on the other side. There's 2 slits, 2 holes, boom, boom, we're done. That's not what happens. What we end up seeing is that if we look at a point somewhere off from like a center axis, okay, what we're going to see is that the light coming through this right here and the light coming through this right here are actually going to have to travel different path lengths to get to this point. If we look at this, and let's draw the line, these 2 lines are actually a different length. If we drew more lines, it would kind of become apparent really quick because, in theory, a line way, way, way further down just naturally looks much, much further. Okay? So, you know what? Let's just make this a little clearer by like zooming in on our slit to an extent. Okay? So let's just kind of redraw this. Let's just pretend that our other slit was down here. Much, much bigger viewing screen. Okay? When we look at this here, the green is a much shorter line than the orange. So we know there's a path length difference. Now, we can describe a few things here. We can call the difference between these 2 kind of center regions some length d. Okay? And let's describe the distance between the slits and the viewing screen as some length L. Okay? And let's set up something here that we're going to say, like, for a small angle, because this is really a zoomed in amount, we're going to say that these angles here are about the same. Okay. Whoop. Something's buzzing. What is that? Now, with this setup here, you can figure out the change or the difference in length between the green and the orange line. So you can find the change in length from the green line to the orange line. Okay? If you can do that, you'll be in a good spot. The second thing you need to think of is what needs to occur in order for the wavelets of light to either constructively interfere or to destructively interfere. And to do that, you need to start thinking about waves. Remember, if we have a wonderful sine wave and we have something that is out of phase with it, this is destructive interference. While one's going up, the other's going down, and in the end, if it's perfectly constructive, they would cancel each other out. Okay? On the flip side of things, if we had a wave that was like that, and one that was right on top of it, as best as I can draw, these would be constructive waves. Now, in order to have a destructive wave pattern, the waves have to be offset by a factor of lambda over 2, half of the wavelength. For constructive waves, you need an offset of either 0 or lambda or some multiple of lambda here. And I guess this could technically be some multiple of lambda over 2. Okay? So if you kind of think about that, that is the offset in the length you're needing there. This is basically the setup to find Young's double-slit derivation. What I'd like you to think about is, and this is kind of the big hint, what can you kind of do right here to set this all up? Okay? And I'll just leave it at that. We'll see that in class whenever you try that out tomorrow. Okay?